7.4, concentration of a solution. This is where the math hits the chemistry concepts. So as we're talking about this section and we're going along and they're showing you different formulas, please write down these formulas so you can use them when you need them. So concentration of a solution. The concentration of a solution is expressed as the amount of solute over the amount of solution. Now there are different formulas and different concentrations that we are going to be using, different units of concentration. One of them is called mass percent, where you're going to have the mass of the solute over the mass of the solution. Another calculation is the volume percent, which is the volume of the solute over the volume of the solution. Another is the mass volume percent, which is the mass of the solute over the volume of the solution. And then there's molarity, which is the moles of the solute over the liters of solution. So mass percent. Here we have the concentration by mass of a solute in a solution. So it is the grams of solute over the grams of solute plus grams of solvent, which, if you remember, solute plus solvent equals solution. So that's why we say here the amount in grams of solute in 100 grams of solution for mass percent. So let's say you needed to find the mass percent. You're weighing out your solute. You put it in your beaker and it's 8 grams. Then you put water in, and it's not that you put in 50 milliliters of water. It's that you put in water till it equals the mass, the 50.00 grams of the whole solution. The calculation of mass percent requires the grams of the solute, in this case the grams of KCl, and the grams of the whole solution, so which is the grams of the KCl plus the water that you added. So you will notice when you get those values, you then plug them in. 8 grams of solute over 50 grams of the whole solution times 100 is going to give us 16% mass over mass. So the guide to calculating solution concentration. Determine the quantities of the solute and the solution. Write your expression, i.e. the formula, and then substitute the solute and solution quantities into the expression. So press pause and do this problem. All right, you're back. A solution is prepared by mixing 15 grams of sodium carbonate and 235 grams of water. Calculate the mass percent of the solution. Okay, so you know that the formula is the mass of the solute, which is the sodium carbonate, over the mass of the whole solution, which is the 15.0 grams of this plus the 235 grams of water, then times 100 to make the percent. So let's see, 15 plus 235 is going to be 250. So when you do the math, you're going to have 15 grams over 250 grams of solution times 100. And so when you do, you're going to get 6.00% sodium carbonate. Now, volume percent is another type of calculation. Depending on the needs, they can also calculate volume percent. The volume percent is the percent volume of solute to the volume of the whole solution. And this would be, for example, if you're using liquids. So for your solute. So you'll notice our formula: milliliter of solute over milliliter of solution times 100 for our volume percent. Now the solute in 100 milliliters of solution, conversion factor for volume percent, would be milliliters of solute over milliliters, 100 milliliters of the whole solution. Now, here's another one, is mass over volume percent. This one is the one that is actually more widely used in hospitals and pharmacies, that you probably will run into contact with in your schooling and in your career. Since most people taking this class, you're going to do something with in the health fields of some sort. So what that is, and that is because you're going to put a solute that's probably measured in, it's a solid sort of solute, and you're going to put it in milliliters of your solution. And so that is the percent mass of solute to volume milliliters of solution. Then we have our formula here is grams of solute over milliliters of solution times 100. We could say the solute in grams in 100 milliliters of solution to find the mass volume percent for our conversion factor. It's another way to do that. So write the two conversion factors for each solution. So in other words, if we were going to need to use this in a dimensional analysis type problem, or if we wanted to just really understand what this meant, when we have mass over mass, that's going to mean 8.5 grams of sodium chloride over our 100 grams of the whole solution. Now, you could also have written it another way, 100 grams of the whole solution over 8.5 grams of sodium hydroxide. Now B, on a volume, this is going to mean 5.75 milliliters of our ethanol over 100 milliliters of our solution. Or we could have said 100 milliliters of solution over 5.75 milliliters of ethanol. And for our last one, 4.8% HCl, mass over volume, then we're going to say 4.8 grams of HCl over 100 milliliters of solution, or vice versa. If we needed to invert it, we could say 100 milliliters of solution over 4.8 grams of HCl. Now, in chemistry, if you take more chemistry and you're going more the chemistry route, the unit of concentration that chemists use in the chemistry portion is molarity. It tells us things in a different way. It's just it's another unit of concentration, but it's molarity. What molarity is, it's the moles of solute over liter of solution. So it's the moles of solute per liter of solution. So you'll notice our formula is molarity equals moles of solute over liter of solution. So if we had a 1 molar solution of sodium chloride, that would mean it is 1.0 moles of NaCl over 1 liter of solution. And the way that you would go about doing this is you would have put in 1 mole of sodium chloride in your flask here, and then we're going to add water till the 1 liter mark there, and then that is your 1 molar sodium chloride solution. So you'll notice you weigh out 58.5 grams of sodium chloride. Why? Because that is how many grams are in 1 mole. And you go, where did that number come from? Well, look up the molar mass of sodium on the periodic table of Na and the molar mass of your Cl on the periodic table. You add them together, and that is your 58.5. Then you're going to add water to the 1 liter mark in your flask. So let's do some calculations here. What is the molarity of 0.500 liters of NaOH solution if it contains 4 grams of our sodium hydroxide? Well, if you remember, our formula for molarity is moles over liter. So we have to convert from grams of sodium hydroxide to moles of sodium hydroxide. We look up the molar mass. Hydrogen is 1, oxygen 16, or sodium is 23. You add them together and that makes 40. So we have these conversion factors that 1 mole of sodium hydroxide is 40.0 grams, or we could have inverted it, 40.0 grams of sodium hydroxide is 1 mole of sodium hydroxide. So knowing that we have 6 grams of sodium hydroxide and need to convert it to moles, then the conversion that we're going to use, you'll notice, is 1 mole of sodium hydroxide over 40 grams of sodium hydroxide, so that the grams of sodium hydroxide cancel out. So 6 times 1 divided by 40 equals 0.150 moles of sodium hydroxide. Now we know that the volume of the solution is 0.500 liters, so we're going to plug those into our formula now. Moles of solute, which is 0.150, over liters of solution, 0.500 liters of solution, and so our concentration, i.e. molarity, of our sodium hydroxide solution is 0.300 molar sodium hydroxide. What's the molarity of 0.225 liters of a KNO3 solution containing 34.8 grams of KNO3? Press pause and see if you can do this. So first of all, since they're asking for molarity, we know we have to use our molarity formula, which is moles of solute over liters of solution. So we have to go from 34.8 grams of our potassium nitrate to moles of it. We look up the molar mass of potassium, we look up the molar mass of nitrogen, we look up the molar mass of oxygen, multiply that one by 3. When you get all of those and add them together, it is 101.1 grams of KNO3 is 1 mole of KNO3. So depending on how we need to use it, we have these 2 different conversions here. So now then it mentions that we have 34.8 grams of potassium nitrate. We need to convert that to moles. So we're going to use the conversion 1 mole of potassium nitrate over 101.1 grams of potassium nitrate. Why? So that the grams of potassium nitrate cancel out. So 34.8 times 1 divided by 101.1 is going to give us 0.344 moles of potassium nitrate. Now we know what our solution's volume is, 0.225 liters. Now then, we're just going to plug those values into our formula. Our formula is molarity equals moles of solute over liter of solution. So 0.344 moles of potassium nitrate over 0.225 liters of solution gives you 1.53 molar KNO3. The units of molarity are used as conversion factors in concentrations with solutions, which is just what we got through mentioning. So you'll notice here at this table are different, all of our different concentration units and what it means.